Hello, and welcome to the Toshogu Podcast, where we break down the latest news, breakthroughs, and ideas shaping the future of artificial intelligence.
Glad to be here.
Today, we are exploring a massive industry-wide shift. For years, the prevailing narrative was that raw artificial intelligence models were the ultimate prize.
Right.
The entire focus was on having exclusive access to the absolute smartest, most scarce digital brain. But we are watching that scarcity vanish in real time. We are seeing a profound transformation where the real magic, the true competitive advantage, is moving away from standalone models and directly into the systems, the security architectures, and the collaborative environments built around them. Let us begin.
Yeah, to really grasp the magnitude of this shift, we have to start by looking at the fundamental economics of intelligence right now.
Okay.
Because the barrier to accessing top-tier, frontier models is, it's absolutely plummeting across the board.
Okay, let's unpack this, because we're seeing this play out in a very, very aggressive way.
All right.
OpenAI recently just took a sledgehammer to their developer pricing. They slashed the API and credit costs for their GPT 5.6 Sol model by more than 20%.
20%, which is massive.
Right. And for anyone not building software day to day, when we talk about API and credit costs, we're basically talking about the toll that developers pay every single time their application asks the AI to, think or process a piece of text.
Exactly. It's the cost of doing business.
Yeah, and OpenAI didn't just run a brief, weekend flash sale here. This is a locked-in promotional rate running for the next 3 months, so at least through late November 2026.
Right. And the ripple effects across the ecosystem they were instantaneous.
Yeah.
AWS immediately mirrored this exact price reduction inside Amazon Bedrock, which is it's their cloud service for hosting AI.
Oh, wow.
Yeah, they brought the cost of running that same OpenAI model down to an incredibly low $4 per million input tokens and $20 per million output tokens.
Let me quickly translate that for the listener, because tokens can sound kind of abstract. A token is roughly a piece of a word. So 1 million input tokens is like handing the AI the text of about a dozen average-sized novels to read all at once.
Yep.
And it only costs $4 to process that entire stack. That is astonishingly cheap.
It's basically free at that point.
Right. And when you step back and really look at those numbers, it fundamentally changes how you approach building software. It reminds me of the early days of computing, or even better, think about electricity or raw silicon.
Oh, that's a good comparison.
Yeah, because decades ago, just having physical access to computing power or raw materials, that was a massive business moat. But today, silicon is everywhere. Electricity is in every wall.
Yeah.
Frontier models are becoming exactly that. They are highly necessary, absolutely foundational to making the machine run, but they are no longer the single thing you build your entire business mode around.
No, not at all.
They're becoming a utility.
Exactly. What's fascinating here is the strategic motive driving where these models are actually showing up. To picture what's happening, imagine the AI industry has shifted into this, bustling, chaotic digital marketplace.
Okay.
It's not just about the price of the goods dropping, right? It's about the distribution channels completely opening up in ways that defy traditional tech rivalries.
Yes.
We are seeing models appearing in environments you would never have expected even a year ago.
Like xAI launching Grok 4.6 on the Google Enterprise Agent platform.
Yes.
When I saw that headline, I honestly had to do a double take.
It is a remarkable dynamic. You have a highly capable model developed by xAI, which is explicitly positioned for advanced coding, agentic work, deep knowledge tasks.
Yeah.
And it features a massive 500,000 token context window.
And just to clarify that jargon for a second, a 500,000 token context window means this AI can hold the equivalent of about 10 standard novels of information in its active short-term memory all at once while it works,
Right.
without forgetting what it read on page 1. Plus, it has configurable reasoning levels.
Exactly. And yet, there it is, sitting right inside Google Air's ecosystem as a preview release.
Oh, wait, why?
Whoa.
Because Google has Gemini, right? They have their own incredibly capable models that they've spent billions developing. Why on earth would they bring a direct competitor like Grok into their enterprise platform? It seems totally counterintuitive.
Because the hyperscalers, and so companies like Google and Amazon, have realized that owning the customer relationship is ultimately far more valuable than simply owning the underlying model.
Oh, interesting.
Going back to that bustling marketplace visual we talked about, Google doesn't actually care if you buy an apple or an orange. They just want to own the supermarket you're shopping in.
Right.
They want to be the ones handling the billing, managing the governance layer, and providing the deployment environment. If they provide the best enterprise platform, they keep the customer locked into their ecosystem, regardless of which model that customer chooses to use on any given day.
So they are intentionally making the distribution layer cloud neutral.
Exactly. It's the ultimate infrastructure play.
You don't need to manufacture every product on the shelf if you own the entire supermarket.
Precise.
And for the developers and builders listening, this means vendor lock-in around a specific model is essentially dead. You shouldn't be architecting your software to only work with one provider's specific API anymore.
Absolutely not.
Yeah.
The application layer needs to be built with the core assumption that models will be swapped in and out continuously.
Wow.
You should be evaluating a model like Grok on Google for its quality per dollar ratio on your specific internal tasks, rather than just relying on its baseline benchmark, reputation, or, brand name.
Right.
Premium intelligence is now a variable cost input.
But here's what I'm trying to wrap my head around. If the raw brain is getting cheaper and popping up everywhere, what actually separates a good AI product from a bad one?
That's the question.
If we all have access to the exact same cheap intelligence, where is the competitive edge? And it turns out it's the harness you put around it.
This brings us to the architecture surrounding the models. Because if baseline intelligence is cheap and ubiquitous, the differentiator becomes how effectively your system can utilize and amplify that intelligence.
And the results we are seeing from optimized architectures are staggering. NVIDIA just published some massive data on their Agentic variation operators, or AVO architecture.
AVO stuff is wild.
Yeah, they took Claude Opus 5, dropped it into this AVO system, and the performance jump was unbelievable.
The numbers really are striking. Let's look at the ARC AGI3 benchmark to understand the scale of this.
Okay.
This specific test is notoriously difficult because it evaluates long horizon logic, spatial reasoning, and adaptability across multiple complex environments.
And hard.
Yeah, a raw model alone generally struggles with this. The baseline performance for Claude Opus 5 was sitting at about 30%.
Which makes perfect sense, right? When you just ask a raw model to solve highly complex, multi-step problems in a single shot, just typing a prompt and hitting enter, it hits a cognitive wall. It can't hold all the moving parts together perfectly on the first try.
Right. But when NVIDIA placed that exact same model inside the AVO architecture, its performance skyrocketed to a perfect 100%.
That is insane.
It completed all 183 levels across 25 different environments.
It went from a failing grade to absolutely perfect without changing the underlying model at all.
No, one bit.
So how does that actually work mechanically? How does a system wrap around a model and make it that much smarter?
If we connect this to the bigger picture, it proves that a weaker or cheaper model operating inside a superior system can easily outperform a stronger model that is just being used as a basic single-shot chatbot.
Ah, I see.
The AVO system provides critical infrastructure that a raw model lacks. So things like persistent memory, dedicated supervision, the ability to use external tools, and iterative execution.
Wait, let me make sure I understand the dedicated supervision part. Is it basically acting like its own manager?
Precisely. Essentially, the AI plays two distinct roles.
Yeah.
One instance of the AI acts as the worker, attempting to write the code or solve the logic puzzle.
Okay.
But before that solution is finalized, a separate instance of the AI, acting as the supervisor, reviews the work.
Wow.
Yeah, the supervisor might say, no, that logic will fail in step 3, try again. It creates an internal debate.
So iterative execution means it's actively trying a solution, realizing it failed, analyzing why it failed, and generating a new approach, all without a human having to sit there and click regenerate.
Exactly. It manages its own state over a very long time horizon with built-in feedback loops and recovery mechanisms.
That's incredible.
And NVIDIA didn't just run this on a synthetic benchmark, They reported having this AVO system operate continuously for 7 days on a real-world application.
Wait, 7 days?
7 full days, specifically doing GPU kernel optimization.
For the listeners, GPU kernel optimization involves writing the incredibly complex, low-level code that tells graphics processing units exactly how to calculate data.
Yeah, it's tough stuff.
It is deep, highly specialized math. And this system just churned away at it for 7 straight days.
Over those 7 days, the system explored more than 500 different directions and successfully produced 40 committed functional kernel versions.
Unbelievable.
This isn't a prompt and response dynamic anymore. It's an autonomous worker grinding through a massive problem space, testing and discarding hundreds of dead ends.
Okay, I have to push back here, though.
Sure.
Running a system continuously for 7 days autonomously, doesn't that sound like a recipe for a runaway train?
Uh-huh.
I mean, how do we keep it on the tracks? If it's exploring hundreds of directions completely on its own, what stops it from committing terrible code or eating up massive compute budgets or just spiraling into a hallucination loop that breaks production?
That is the exact right question to
Yeah.
ask, and it's as us why the industry is rapidly shifting its focus away from just the models.
Okay.
The real product advantage is shifting to the AI operating system. The layer that handles the planning, the state management, the retries, and crucially, the boundaries.
Mm-hmm.
For anyone building in this space right now, you need to deeply study system patterns like AVO
Mm-hmm.
rather than obsessing over which model has the highest raw benchmark numbers.
So the harness isn't just about amplifying the model's capabilities, it's equally about restraining and directing it,
Exactly.
which makes perfect sense. If you have an engine that can run autonomously at top speed for 7 days straight, the software bottleneck isn't the engine anymore, it's the brakes.
Yeah.
You absolutely need world-class brakes.
Precisely. And that necessity for strict infrastructure-level governance for these autonomous systems is driving the next major evolution in the stack. We had to secure the perimeter.
So what does this all mean for how we actually build these guardrails? Because for a long time, we tried to control AI behavior just by telling it what to do in the system prompt.
Right, yeah.
Typing out, "You are a helpful corporate assistant, do not access restricted files, do not do anything malicious."
The classic text-based system prompt approach, it relies on the model's behavioral fine-tuning to hopefully follow your instructions.
Right. And trying to secure an autonomous AI with system prompts just feels fragile. It was kind of like politely asking a toddler not to touch the hot stove. Sure, they might listen most of the time, they might understand the instruction, but the moment you turn your back, that hand is going right on the burner.
Oh, absolutely.
The new infrastructure controls we are seeing introduced are moving away from asking the AI to behave and instead installing actual physical baby gates bolted into the walls.
That's a great start, but let's push the analogy further to understand the mechanics of the network layer.
Okay.
Prompts merely influence what an agent tries to do, but only hard infrastructure determines what an agent can do.
Right.
We are seeing major moves to establish immutable boundaries. AWS just published their reference approach for the Amazon Bedrock Agent Core Gateway, and it's a game changer for enterprise security because it moves control entirely below the prompt layer.
Okay, break that down for me. How does the gateway actually work?
Historically, if you built an agent, you might give that agent its own API keys or passwords embedded right in its code,
Yeah.
so it could access a company database
Yeah.
or a third-party tool. The Agent Core Gateway completely changes that architecture. Think of the old way, like giving a contractor the master keys to your entire corporate office.
Right. Very dangerous.
The new Agent Core Gateway is like a highly secure reception desk.
So the AI worker has to walk up to the desk every single time it wants to do something.
Exactly. The AI never actually holds a key. It has to state exactly what room it wants to enter and why. The gateway centralizes all authentication.
Oh, wow.
It checks a hard-coded policy to see if this specific agent in this specific context running this specific workflow is actually allowed to open that door.
That's smart.
If it is, the gateway unlocks that single door remotely.
Yeah.
It also handles all the audit logs, cost attribution, and PII controls.
Which are the filters that strip out personally identifiable information like social security numbers or private emails before the AI even sees the data?
Yeah.
So the agent itself is completely stripped of credentials. It's no longer carrying the keys to the kingdom in its pocket.
And NVIDIA released similar architectural guidance simultaneously, heavily emphasizing this exact agent security stack.
Mm-hmm.
They are hammering home the principles of least privilege, meaning the AI only ever gets access to the bare minimum data needed for the task at hand.
Right.
They mandate strict environmental isolation, explicit authorization, and comprehensive auditability below the agent boundary.
It's a fundamental architectural shift. The enterprise control plane is no longer just a nice-to-have security feature,
Yeah.
It is now a distinct, mandatory product category of its own.
Yes.
If you are deploying agents into an enterprise environment, you cannot rely on the model being polite to keep your company safe.
You simply can't. The risk surface is entirely too large when an agent is running autonomously for days at a time.
Yep.
Even if you don't use AWS,
Looking at the agent core gateway structure is incredibly valuable. It's flow moving from identity to the gateway, checking the policy, and verifying against the registry is the ultimate blueprint for any serious multi-agent architecture you might build.
Because at the end of the day, you need absolute certainty that your persistent AI worker isn't going to accidentally delete a production database because it hallucinated a SQL command.
Exactly.
But once we have these agents thinking deeply over days and safely locked behind those infrastructure gates, they can't just live in an isolated terminal window. They need to join the actual human team.
This is where the concept of the AI operating system starts to seamlessly interact with our human operating systems.
Yeah.
The interface for these tools is undergoing a radical transformation. We are moving away from the single-user chat interface and stepping into shared collaborative enterprise spaces.
Here's where it gets really interesting. GitHub recently introduced shared agentic work using Copilot, but directly inside Microsoft Teams.
Think about the workflow change there. Instead of one developer sitting alone in their their local coding software chatting with an AI assistant in a private window,
Right.
you now have a scenario where a whole team of developers can tag the GitHub agent inside a standard Teams channel conversation.
This is such a fascinating psychological shift.
It really is.
It's one thing to use an AI as a personal calculator. It's completely different to have an AI sitting in your Teams chat channel, watching human politics and technical debates unfold.
Oh, yeah.
3 different engineers can debate a problem in the chat, agree on a technical direction, and then point the Copilot agent at the task right there in the thread.
And the system sends that agent into a secure cloud sandbox to actually execute the work. It's not running locally on someone's laptop.
Okay.
It's operating in a governed cloud-native environment. And crucially, administrators can set policies requiring human approval before any of that agent-authored code is allowed to merge into the main project.
And for the non-developers listening, merging code via a pull request is basically submitting your final draft to the boss for review.
Right.
It's treating the AI exactly like a junior developer who works in the team room. You give them a task, they go to their desk in the sandbox, they do the work, and then a senior developer reviews the draft before it goes live.
Exactly.
But the AI is just living in the chat channel, visible and accessible to everyone.
This raises an important question about the future of work interfaces. The interface is expanding outward. Humans are now supervising persistent AI workers together.
Wow.
It is a shift from a one-to-one tool to a multiplayer AI environment.
If you have the opportunity, testing this Copilot Teams integration is highly recommended. Not even just for the specific coding capability, but to physically experience this new interaction model.
Yeah, you have to feel it.
Seeing one persistent AI worker being directed by multiple humans in a shared space completely changes how you think about delegating work.
But here is the irony of this whole shift. We're talking about these agents like they are software ghosts living in the cloud, casually hanging out in our chat rooms.
Right.
But to keep an AI thinking continuously for 7 days straight without crashing, the bottleneck isn't just the software architecture anymore, it's the physical world.
Right. Which brings us to the actual physical infrastructure required to make this virtual coworker exist in the first place.
We saw a major announcement from Cloverleaf Infrastructure noting a strategic partnership and minority investment from NVIDIA to build out what they are calling AI factory infrastructure across the United States.
And we aren't just talking about shipping out a few racks of GPUs to a standard server farm. We are talking about the foundational layer of physical reality.
Exactly. They are focusing on powered sites, advanced cooling systems, land acquisition, and facility design using NVIDIA's DSX platform.
Wow.
Which is essentially their blueprint for high-performance data centers. The competition in AI infrastructure is no longer simply about who designs the fastest piece of silicon. The strategic assets now include the electrical grid capacity, the thermal management of entire data center buildings, and the physical land footprint required to house these massive systems.
It is the ultimate contrast. We interact with these highly ephemeral virtual intelligence agents in our digital chat rooms, treating them like software ghosts. But to sustain that illusion, to keep that agent alive and persistent for 7 days straight optimizing code, it requires pouring thousands of tons of concrete.
Yeah.
It requires securing massive water rights to keep the servers from melting down and tapping directly into high-voltage electrical substations. The virtual requires the deeply physical.
And as we move away from quick, single-shot queries and move toward continuous, persistent agentic loops, The energy draw and the physical infrastructure demands are only going to compound massively.
Yeah.
The physical AI factory is the literal engine room for the virtual AI operating system.
We've covered an immense amount of ground today, spanning from the plummeting economics of API calls to multi-agent architectures, all the way down to the concrete poured for data centers. It is clear the entire landscape is reorienting itself.
To synthesize all of this into a clear framework, we can really look at the market converging on a new 5-layer stack.
Let's break that stack down so listeners have a mental model to take away.
First, you have the models. As we saw with Grok on Google and the massive price drops, models are becoming interchangeable, vastly cheaper, and widely distributed across multiple cloud platforms.
Okay, got it.
Second is routing. Because models are interchangeable, you need the architectural ability to dynamically select the right model for a specific task based on cost, latency, privacy, and quality in real time.
Makes total sense. You route the task to whoever can do it best and cheapest at that exact millisecond. What's the third layer?
Third are the harnesses. This is what we saw with NVIDIA's AVO architecture. It provides the memory, the planning, the internal supervisors, and the iterative feedback loops that amplify the baseline capability of whatever model you route it to.
Right, the brakes and the manager.
Exactly. Fourth, the control planes. This is the AWS Agent Core Gateway concept.
Okay.
It's the mandatory infrastructure that acts as the secure reception desk, enforcing trust, permissions, sandboxing, and audit logs.
The heavy iron infrastructure replacing our fragile system prompts.
Exactly. And finally, the fifth layer is workflow integration. This means distributing the agent into the tools and conversations where humans already work, just like the Copilot multiplayer integration in Microsoft Teams.
So the entire strategic shift of the industry is moving from just procuring a standalone AI model to architecting a full-blown AI operating system.
Yes.
It's a fundamental rethinking of how intelligence is deployed, managed, and physically powered.
It really is. The raw model is just the processor now. The surrounding system is the actual product.
Which leaves me with a thought I can't quite shake. We are currently building these incredibly sophisticated harnesses to manage AI. You know, systems that supervise, evaluate, retry, and carefully manage long-horizon execution for these digital workers. But if the systems managing these agents are getting this good at evaluating, recovering, and executing, how long until the agent harness starts optimizing our human workflows instead of us directing theirs? That's all for today's episode of the Toshogu Podcast. If you enjoyed it, like this episode, subscribe, and join us next time for the latest in AI. Until then, keep building what outlives you.